Hello and welcome to the course of Aerodynamic Design of Vehicle. This is Unit 5, Meshing. In this unit, we are covering the basic aspect of meshing. And in this lecture, I will give you a light demo of how to mesh a pipe junction. I will give you 3 videos which I have created and uploaded on my YouTube channel. So from there, I have downloaded that video and inserted in the PPT. So the content of today's lecture is introduction of the geometry, and then we will import the geometry. How you will import I will tell you, and then we will create block. Blocking is a very basic strategy of creating hexa meshing in ICM-CFD, and then we will associate the edges and points, vertex and curves. This is required to know that the mesh is projected on the curve. Then we will supply the mesh parameters, nodes and refining, etc. And finally we will create part name and apply the boundary condition. So in the coming lectures, in the coming slides, I will show you how to create a mesh for the 2D pipe junctions. So these are pipe junctions. We have an inlet and a large inlet and then the outlet. And all of that dimension is given. Finally, we will achieve this type of mesh which is refined near the solid wall, and in the next slide I will show you how. So this tutorial is about the meshing of a 2D pipe junction. So the geometry file is given in your ANSYS directory. Just go to geometry, open geometry, and go to where your ANSYS file is installed, and go to ICM-CFD samples and CFD tutorial file, and this is the 2D pipe junction geometry. So double click. Yes. So we have imported the already given geometry file with the ANSYS software. So you can see here points, parts, right? So make points large, so you can see it now, right? So the first step towards hexa meshing is blocking. So first we will do blocking. We will generate blocking. Go to the blocking tab, select create block, change part name to fluid, create block, type 2D planar and apply. So a rectangular box has been generated. So we will now modify this block to confirm the shape of the this large pipe and this small pipe, right? So go to the move vertex command, right? And select this, move this vertex to this point and this vertex to this point and this vertex to this point, press middle mouse button, right? Now we will split these blocks and move the vertices in so that they can take the shape of this geometry. So first we will split this single block, right? You can see this block. Currently now we are having one single block. We will split and move the vertices to this corner point. Go to the split vertex, split block command, press left mouse button, select first tab. Oh, now split by this way. Again split this edge. Again, now turn the block of, now go to the move vertex command, move vertex, move this vertex to this point, 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 this vertex to suppose these points, right? Press middle mouse button, right? So turn the blocks on, right? Now we can see that we are having this block and this block extra, so we can delete this. So one block is have taken the shape of this smaller pipe, this for larger pipe, and this these three blocks. So these two blocks are extra. We will delete these two blocks, right? Now again we will make some splits and move the points to take the shape of this pipe. So again go to the split block command, split, one split here and one split roughly here, right? Now go to the move vertex command, move this vertex roughly to here, this vertex roughly to here, this vertex to roughly to here, this to here, right? So finally our one block was splitted into multiple blocks and our blocks have taken the shape of larger pipe and smaller pipe. So in this part we will associate vertex to the points and edges to the curve and supply node values to the edges. So go to the association, go to the associate vertex, select vertex and select again point. So your vertex and point has been associated and vertex has moved to the point again. Similar here, similarly here, here, double click, 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 right? So your vertices has been setted, has been fixed to the points of the geometry. Now we can adjust some these edges, right, like this. And now we will associate the curve and edges. So again go to the association tab, select associate edge to curve, select this large inlet, press middle mouse button, select curve, press middle mouse button, and association is done, right? So again we will select all these curve in one go, press middle mouse button, select this curve, okay, right? Similarly here, oh sorry, so we will associate here just to the curve single, uh, so go to the turn off curve. So this is left, turn curve on, select, okay. Now all the edges has turned green, which are
coinciding with the geometry. So all the edges has been associated with the curve of the geometry. Now we will supply nodes to these edges. Go to the pre-mesh parameter, select this edge parameter, select this edge, supply number of nodes say 20, copy to all parameter, copy parameter to all parallel edge, apply. Select this, supply node numbers 30, apply, select this 20, apply, select this 20, apply, select this 30, apply, select this 50, apply, select this 10, apply. Now go to the turn pre-mesh on. Yes, right, your mesh has been created. Now save this project. Right, one more thing, go to the pre-mesh parameter, convert to unstructured mesh format. So in the next lecture we will supply boundary conditions, and we will see the quality of the mesh.
In this part we are going to create parts name for the inlet, outlet, and apply boundary conditions. So just turn off the mesh. Right, now we will create parts name. So go to the parts, right click, create parts, right. Select entity, this make the curves on. So select this entity as inlet, right, and apply. So now you can see that in the model tree parts inlet has been generated, and you can on and off. So you can on and off and identify this is inlet. So in a similar way we will select outlet, and apply, right, and this is the small inlet, and apply, and there is outer wall, large pipe, and apply, and this is
Now we want to name these walls and these small inlet walls.
so again go to create parts and select entity, select this, change name to small pipe, left wall, apply, similarly select this, change small pipe to right wall, apply, and select this. So this whole curve has been selected, but as we want to have this passing open, so we will split this curve and delete this point, delete this section. So to do this, we first have to deassociate it with. So go to the blocking, association, deassociation, edge. So turn the edges on, select and apply. Right. Now go to the geometry, create or modify curve, segment curve, select this curve and these 2 points to segment this curve. Now we can delete this. So go to the delete curve and select this portion only. And now this has been deleted. So now we will name this inner wall and 1 and inner wall 2. So go to the part name, right click, create part, select this inner wall 1, apply, select this inner wall 2, apply. So now we have created all the parts name. So you can see here from here inner wall, turn the curve and edges off. So this is inlet and this is inner wall 2, inner wall 1, outlet, outer wall, outlet, small inlet, small pipe left wall, small pipe right wall. Right? So we have inlet and outlet and small inlets. So every entity we have created name. So now we will save this and we will now apply the boundary condition. Alright. So before moving to this, once again go to the pre-mesh, see your mesh. So this part we have associated. So we will associate this again with this corresponding edges, right? So you can see that mesh is not projecting to this curve. Once we will associate these edges to curve, mesh will project to this curve. So again go to the association, select, turn pre-mesh on, off. So now select this edge, press middle mouse button, select this curve, press middle mouse button. Right? Similarly, select this edge, press middle mouse button, select this curve, press middle mouse button. So now you can again turn pre-mesh on. Yes, yes. So now mesh lines are projected on this curve also, right? So once again go to the pre-mesh and convert to unstructured mesh, replace that. Now we will convert into a fluent importable format. So go to the select solver, and output solver is Fluent, structural solver is ANSYS apply. Now go to the boundary condition, edges. So at the inlet, we have to provide velocity inlet. At the inner wall, create new wall, right? Or you can copy and paste on this, paste again. So outer wall large pipe is also wall, paste wall boundary condition, and outlet create pressure outlet, and at the small inlet again velocity inlet, and at the small pipe left and right is wall. So you can create or paste it. So create, you can change it also in Fluent once you have imported the mesh file in Fluent. Now accept. Yes. Now go to the right output, right input format. Go to the 2D pipe junction files. So select hexamesh, save, replace it, save project, hexamesh, open. So you can select 2D, you can change your file name as pipe junction, and done. So in the desktop in 2D pipe junction folder, a .msh format will be generated, which you can import into the Fluent. So these are the references ANSYS courses which the ANSYS has officially put on this web link, and this is the link of my YouTube channel where I have uploaded all the 3 videos related to the meshing of the hexa, meshing of the pipe junction. Thanks.